So, I was asked to go over virtual and abstract functions in a little bit more detail, just because I guess we want to focus on actually using those because they are definitely useful as far as object-oriented programming. So I wanted to take a little bit longer today to talk about that, and then maybe at the end of the class we'll talk about assignment 5. So I feel like there's something else I want to mention. Oh, right. So exam is next week. It is on Wednesday. I'll probably just put an announcement on Canvas just so everybody's clear on that. It is Wednesday, same class time as normal, and it will be via Canvas. And it should be a combination of multiple choice and free response. I've written a few questions. I haven't gone back and looked what everybody else has written yet, but we've kind of got like a pool of questions, and I think we're going to prune that down this week, and then the exam will be on Wednesday, and we'll do some review on Monday, just so everybody's on the same page. And if I find out that there's like any questions on the exams that I don't think I covered well, then we'll talk about that as well. And I guess the date for that I think is October 7th, just so that's clear. And then the other thing that was part of the announcement that I got was starting with assignment 6, which is the one that you should be doing after the exam. I assume the week after. Do we have an assignment next week since we have a test? I am going to try not to give one. There's one this week, and I've extended it to Sunday rather than Saturday for this one because I do think it's another kind of difficult one. I don't think we're going to do one that week. I think we're going to wait until the week after the exam. At least I'm going to try to do that. I don't know. If they ask me to, then I suppose I'm kind of stuck, but yeah, I don't think we will. Right, and then the other thing was starting with that assignment, the one that's going to be assignment 6, there's going to be a write-up component now to the programs, so it'll just be like a few questions that you have to answer. So just submit a text file, I guess. When we get to that, we'll come to it. Just figured I'd give you a heads up before we end up having to do that. Any other questions before we get started? Oh yeah, sorry. I guess last thing, it covers up to virtual functions and abstract classes in the syllabus. So I know we went over operator overloading, but I won't cover that. The review will be on Monday. So we'll do the review right before the exam. Yeah, it'll be on Canvas. And I'm pretty sure we're not requiring anything that like the some of the other classes have been requiring, like the lockdown browser or the thing where they like monitor your webcam or something. So you don't have to worry about any of that, which is good. I think to counter that, so that we don't have to spy on you, we're making the questions a little bit tougher than we normally would. And that's just because you're not actually locked down. So just to prevent Googling as much as we can, the questions are going to be a little bit more difficult, I suppose. Or there's going to be some practical programming problems as well. What chapter in the textbook? Let me actually look at the textbook. Let me pull that open. Assignment 5 syllabus. There you go. Oh yeah, so I guess since I have this open, I will cover, or the exam will cover, from here to here. So obviously you need to know C++ in order to take the exam, but we'll go over classes, headers, just general data abstraction polymorphism, inheriting classes, pointers, and the memory allocation that goes with the pointers, and then the abstract class of virtual functions, which, again, we'll talk a little bit more about today, just to really go over that. And then so there's the textbook. Is there like a table of contents for this? Senior template library. Maybe I should pull this up too so that everybody can see it. Will there be a study guide provided to us? I don't think so. I'm not sure if we're really planning on making one. I mean, I can try to at least like put up maybe an outline of the topics. But pretty much it'll just be the same sort of topics that are on the what's it called, syllabus. So let's see. We haven't done that yet. So I would say it would be. We haven't done that. We're definitely not going to do that. 18, 17, 16. Pointer stuff. Managing functions and data sequences. Yeah, maybe 11. Yeah, I would say probably 11 and then 14 through 18 in the book. I don't see anything for virtual though. Maybe I'm just missing it. Maybe later? No? I don't see it. So I guess 14 through 18 and then wherever they put virtual functions in the textbook. And then I guess also 11 if you want to review that because it's on vectors. It doesn't seem to have anything on virtual, at least just looking at it. I guess Control F, virtual. No, guess not. Well, oh well, I guess that's why we're going over it. Okay, so I guess that's with regards to the exam. Let me move this back over, and then here's assignment 5. I'll talk about that at the end. Okay, so I wanted to talk a little bit more about that virtual and abstract stuff, and the way I wanted to do that is just, at least the easiest way. Oh, do we have limited? Yeah, I assume it's normal class time, like an hour and 15. You might even have an hour and a half, I guess, if you wanted to take the time to, like the in between classes time. But plan for an hour and 15, if anything. I'll have to ask about that. But you definitely do have limited time, for sure. Right, so, yeah, I figured the best way to talk about that would be go back to the same example that we've been doing. That way we're at least on the same page as far as like functions go. So I have the game example open again, where we have this game object, and then we have an inheriting player and a enemy. So I maybe wanted to draw out a little diagram here and then expand upon this so we can start working with some virtual and abstract functions and classes in general. So what I think I want to do is I want to expand this to have 2 new enemy types, one that moves up and down, so kind of like a flying enemy, and then one that walks back and forth and turns around, and then maybe we'll throw in a item as well. So let's do a little bit of an outline here. So we're going to have game object at the top. So everything in our game is going to be a game object. And what we want is they have a couple of things that all of them are going to have, like an ID, right? And they all have access to a static count. And then I think the other one that we're going to focus on here is we all want them to be able to update every single frame of the game. So every time basically the user inputs a control, like right, left, up, down, or jump, then we'll update all of the game objects in the game based off of what they should do on the next frame. So we're going to have a void update. And then does anybody remember the way I can make it so that, or what keyword I put, so that I can make this update be overridden completely in the base class, or sorry, the derived classes? I'm just going to draw this preemptively. So what would I need to put in front of void update to make sure that it actually, yeah, you got it, virtual, right? So if I put virtual here, then that means that I can override the update. Basically just means I can rewrite it to do something different every single time I write a class. Cool. So we got that. And then we will make two classes to inherit from that. So we'll make the player class, which we already have, and I would say that's good enough. Player. And then that will override update, right? So it will give us a different version of update. All right, and so that should already be written with what we had before. But now I'm going to do something different. So let's make an enemy class, and let's also try to not write any code for it. So I'm just going to make an enemy class, but I'm not going to actually put anything in here for now. I mean, if we were to like make an actual game, then maybe I would throw stuff in here and have an advantage to actually having this. But I'm just going to put an enemy class here, and then we're going to make two enemies. One we'll just call like walking enemy. And that will update in a different way. And again, it'll be able to override because the one in the player object was virtual. And then we'll have a like flying enemy. And that will again have some sort of override for its update that will go over. And so I guess we do want this one to have an update. And I want it to not do anything. So I'll remind you how to do that when we actually code it. I guess the last thing we wanted to consider, so this was virtual. Now, which of these classes would be abstract? And then also, what does it mean to be abstract? Does anybody remember? Enemy is abstract? Fair enough, yeah, I'd say so. Because you don't want it to do anything, right? Fair enough. So this is abstract. Yeah, I'll give you that one. That's fair. We'll say this is abstract. And then we'll say that its function itself is abstract, or you'll see maybe on the exam, but definitely in the assignment 5 with the way he phrased it. Try not to cut this off too much. That he also called this in the assignment, which I guess would just be C++ terminology, because there's no real abstract keyword, which is a pure virtual function, which means that it is just it's virtual and it's not actually implemented at all, so it won't do anything. And we should be able to do that in a derived class. We'll try. Okay, fair enough. So enemy is abstract. Is there any other class here that might be abstract as well? Yeah, game object. Yep. So game object is definitely abstract. And then, just to remind everybody, so an abstract class is a class that you don't want instantiated. In other words, it's a class that you should never be able to make a direct variable of. So a game object, I don't want to be able to make a direct instance of that because I want something more specific every time. So if I wanted, let's just say the player or the enemy, those are types of game objects. So I guess I'm not going to make an enemy because we said it's going to be abstract. But if I was to say walking enemy or flying enemy and player, these are all three things that are going to actually live as specific instances in the game, but nothing is going to be just a game object, right? If I was to make a video game and I just put an object and it was a game object, that's maybe not the most well-defined thing, I suppose, because it's not specific enough, I guess is the point. So if you have something that's not specific enough, you want only the things that are inherited from it to actually be instantiated or put into play in the context of your program as variables, then you want to mark it as abstract. Which, again, we can't really do in C++. We can't mark it as abstract, but we're going to consider it abstract. You might put a comment in your code that says it's abstract so that somebody knows not to instantiate it. But in other languages, we do have the ability to mark that, so the compiler will actually take care of it for you. So any questions on why any of these are abstract or what a virtual function is? Okay. So let's take a look at the code then. And let's try to implement this. So I think, for the most part, we already had this done when we wrote it. So void was already, void update was already virtual. I should zoom in a bit. So in the base class, this just applied gravity every single frame. And so maybe I'll move this gravity part right here. Maybe we'll move that outside. So let me put we'll just put it here. Void apply gravity. And maybe that's better because let's just say for the flying object, maybe we don't want it to apply gravity. So in the context of our little side-scroller game, maybe we only want the player to have gravity applied on them as well as the enemy that walks back and forth. But the one that flies up and down, maybe we don't want that to actually have gravity. And another way that you could implement this is just have a gravity variable and set it equal to 0 for that object as well. That would be okay. Let's just, I suppose, assume everybody has the same gravity for now. Cool, so all this does in the virtual void update now is it just adds the object to screen. Alright. So let's go and override the player update then. So let's make this a little taller. So I'm going to remove this one. So I still kind of want the advantage of this update here in my player object. So it really, all it does right now is it adds the object to the screen. So it renders the actual object as a character right in that grid. So I do want that for the player. So it's totally fine for me to call the update version. So consider if I didn't have this line. So if I was to just go write the update function, this would mean that it completely overrid the one from the game object, which means that if I was to call this, it would do nothing. So it wouldn't call the original one because it's marked as virtual. It will just call this one, and then it'll only do the code here. So if I was to put let's just say, for the sake of the example, cout player update. And then we'll say up here in this update, wherever it is, did I scroll past it? Where'd it go? Oh, there it is. So if I was to go into the game object update and say cout updating, and then we'll just put the print character. I know it's hidden behind the thing. You can see a little bit. Print character line. So if I was to print the name of it, just so we can see here who exactly is calling it, maybe I'll throw an inline on this one too. Let's move that back up. So if I was to run it now, just remember in our main we had this loop here that that updated all the game objects that have been instantiated so far. So if I call this or run this program now, I'll get build errors. Oh no. Did I not use namespace standard? I didn't. Okay. Maybe I should just do that. No? Oh, because I can't spell. There we go. PDB, unexpected format. Oh boy. Let me try to fix that really quick. Let's just... Maybe it's having a compiler issue. Let's try to recompile it. No. No, still doesn't work. I can't imagine that's from this line. I suppose I should have tried to run this again to make sure that it worked. I don't know what could have possibly broken this. Maybe it was the fact that I used namespace standard. I have no idea why that would break it. Okay, let's just try putting a standard namespace in front of it. Nope, still build error. Unexpected PDB. I don't know if anybody's encountered this issue before. I've never... I mean, I've had issues where it just won't run it, and it doesn't give you something helpful. Let's see if I can Control-Z my way all the way back to what we had at the beginning and see if it just compiles. No, still broken. I'm assuming something has happened to the project itself. Let's try creating a new project really quick, and if that doesn't fix it, then I will just wave my hands and we'll hope for the best as far as the code goes. I have no idea what issue I could have put in there. I don't think I've changed it since the last time we ran it. I guess in the meantime, does anybody have any questions while I'm having to create a new one of these? PDB. Oh, Google says close Visual Studio, delete project name.pdb, reopen Visual Studio. Okay, I'll try that really quick. So let's close that. I think I still have the directory open. There we go. delete the PDB. Yeah. Okay, there's that. And then we'll reopen it. Hopefully that works. I tried deleting it before. That's usually what I do when it has like an issue in the other version of Visual Studio I use. So let's try running it. Maybe. No. Yeah. Let's just try making a new solution really quick and see if that fixes it. Unfortunately, the struggle of computer science is that sometimes you think things work, and then there's like, you know, it just doesn't. Yeah, so I have to include a header really quick. Over here, I think I called it GameObject.h, right? Yeah. Add new item. Oh no. I clicked on another program and it's gonna copy and paste. Okay. So this is just the same code. Let's see if it actually runs now. If this one gives me a PDB error, then I have no idea what I've done wrong. Ah, okay, it's running. Yeah. I guess it's just corrupted. I don't know. Nothing wrong with the code. Okay, let's zoom in on this. Right, so what we were saying before Visual Studio so rudely interrupted is that we were writing a player object, or sorry, player update, and it was overriding the virtual version from GameObject that we overrode. So here is the GameObject version of it. It's called update, and then we came down here and we wrote a player version of it. So what we were saying is that if we were to just override it, it's going to call the player version for the player, but not the GameObject version of it because it's overridden. But something like the enemy is going to have, well, both called, I guess. It's probably just going to call the GameObject version. So if I call R, you can see that it does two updates. So it has the player update, which is the update that we just said was written for the player, and then we have the GameObject version for enemy. So the player update only calls itself because the GameObject one is virtual, so it won't call the one above it because virtual implies that it's going to override it. And then the enemy version, we didn't write anything for it, so it did go and called the virtual one because it didn't override it. So again, here with the virtual one, the void update player, that only called this one, didn't call the GameObject one, and then enemy we wrote no update function at all. So what it did is it went and it called the player version, or sorry, the GameObject version. So if we were to go again, look at this. We said we weren't going to implement update, so it's going to know to go and call the GameObject version, whereas this one, when we write it, will override it, so it won't go and look up and do the next one. So whenever you call a function that's been marked as virtual, what it will do is it will start at whatever the class type is of the thing that you're calling on, and it will work its way up until it actually finds an implementation that works. So when I call enemy, it will look here first, see that it doesn't work, and then scroll its way up to a GameObject. So if I was to write these and not implement it, it would look first in this class, and if it didn't find it, it would look in enemy next, and then it would keep working its way up. And so it assumes that there's some implementation from where it starts to the root of your class hierarchy, and the compiler won't let you actually not implement it. So your program shouldn't compile if that path doesn't exist. So if I didn't implement update on any of these, but I for some reason tried to use it on that, well, I guess that wouldn't really make a whole lot of sense because the name wouldn't be defined anyways. So that's probably the error that you would end up getting. So any questions on how it decides to call that? So does it make sense why enemy called this one, and player called itself. But not the game object version, I guess. It didn't call the game object version, it just called the player version. So, yeah. So maybe I do want it to be virtual just because I want it to be virtual in the enemy class, but I don't want it to actually be completely virtual in the sake of the player class. So I still want the player class to maybe call the update version from game object. So what I can do is I can actually explicitly call that function that I overrode. So let's leave this in here. So let's leave the player update cout message, and then we'll also update via the game object version. So this is the function that we were just overriding, right? So it was virtual, we overrode it here, and then let's try to call it. So the way we'll have to do that is because we're not referring to a specific instance, and we also want to specify which class we want the update to go to. We need to put the class name in front of it, and then the scope resolution operator just to specify that that's where it came from. So this is static, if you will. And the reason we do this is because if I was to just say update, then it might think I'm talking about the one that I'm currently in. So if I wrote this, it's going to think to call itself the one that belongs to the current class I'm in, which is player. So that's why I have to specify that. And then the other reason might be I might be inheriting from like 3 or 4 different classes down in that class hierarchy tree. And if I do that, maybe I want one specific version that's like 3 levels up versus 2 levels, or just the one above me. So you can specify that using the exact class that you want it to be from. And in a lot of other languages, you can just use the word base, and it will assume that it's the one right above it, and it will do another check similar to what we said earlier, where it'll just work its way up the tree. But in C++, you actually have to specify this is the one I want. This is the exact class that I want to come from. So anyways, let's try to run it really quick, and we should see that it will call both both constructors. Sorry, updates. Or it will do nothing. That's an issue. Possibly because it froze. That's not good. Is it still running? Windows closed. Oh boy. Just having a fun time with Visual Studio today. Yeah, I don't know. Why is it doing that? I mean, this worked last time we ran it, right? Let me comment that out. I don't see why that would cause it to freeze. No, that's definitely not it. Visual Studio is having an off day, I guess. Let's try one last time to restart Visual Studio. If that doesn't work, then I suppose I'm just gonna have to pretend that it works and just describe what the program would do. Let's try to close that really quick and see if it will run. No? Oh, maybe it's just taking a while to run. It says it's loading symbols, so I think the debugger is just really slow right now. It'll get there eventually. I guess we'll come back to it. I accidentally click a breakpoint. Oh, duh. I guess I accidentally was clicking too hard and I set it to stop. Alright, not Visual Studio's fault. I'm just dumb. But okay, it does what we expect it to. So it calls now, because we explicitly said so, it calls the player version of the update. actually right here, and then it calls the game object version. And with the order I did it in, it calls the game object version first before it prints. So you can see I call the game object update, and then I call it there. This is also nice because I can decide if I want to call the base class version of it before or after the current code. So if I didn't have this as virtual, then it always calls the base class version before it executes the main body of this one. So if it wasn't virtual, if this one was just normal void, it would call the base class version of it and all of the ones above it as well before it called this one. So if for some reason I wanted to make sure that the base class version of it runs after whatever code I needed in this one, I can also mark it as virtual to accomplish that as well. Which I don't think is a super common thing. Usually you do want it executed beforehand. But I'm pretty sure there's been a few cases where I thought it would be convenient to do the other way around. Maybe if you have a variable that does something different in a derived class than it does in the base class, then perhaps that's a way that you would want to do it. Okay, so let's actually get on with it. So we wanted to update that, and then our real intention here was that we wanted to make the player actually have, not that, apply gravity. We wanted the player to actually have gravity applied. So I should probably apply that before I add it to the screen. Never mind, this is a perfect example. So here, I want it to apply the gravity before I want it to update it, because this is the rendering part. So when you're doing a game, you want to update the movement before you actually show where the player is. Otherwise, you kind of have like a 1-frame delay in terms of your game. So here I will apply the gravity before the update, and that would be a useful example of overriding, because I can call it afterwards rather than before now. Okay, so that seems good. Let's just really quick, let's go down here and let's put the enemy version of it. So I'm going to mark this one as virtual again, and I could always just not implement it, but for the sake of an example, I'm going to write it, and it should hopefully take it. So I could have just left this blank, and it would have done the same thing, really. It would have just, when I wrote it down here, it would have worked its way up until it found the game object version, because enemy didn't implement it. Now it might actually give you a compiler error if you do that, if you like skip a class, so I do still recommend doing it this way. Does anybody remember, we did it very briefly, what this does exactly? What does it mean to set the function equal to 0? Yeah, that means it's abstract. So the way we have to mark a function as abstract in C++ is setting it equal to 0. Right. So we wanted, we said in this outline, we wanted the enemy class to be abstract, and we also wanted to have a pure virtual function, which is what that is, or in other words, mark it as abstract. And so what that means is that it just does nothing. So here, this is not going to do anything. And I guess actually that's maybe not the best way to explain it, because it's not necessarily not doing anything, because I guess if I wanted to, this also does nothing. So perhaps that's not the best way I could explain it, but rather we're saying it's not implemented. So it doesn't exist. It's not even there to do nothing. So that means that when I write the derived classes, which we'll do here, I suppose, I'm going to have to implement update. Otherwise, it's not going to have any definition for it. Even though I put one up here, so I put one in the game object, which enemy is also inheriting from, it should override it to become abstract. So that will change how things work a little bit. So really quick, let's try to write a class called walking enemy. And that will inherit from enemy. And so I don't see an error right now. Maybe C++ allows it. No, it doesn't. Good. Oh, it even says that. Okay, very cool. So you'll see here it says game enemy cannot be instantiated. So we were changing our idea here to make it so that enemy was abstract. And we did that by marking one of its functions as abstract. So C++ will imply that that object itself is abstract if it contains any abstract functions, which I guess is kind of a good thing because that is really the way it should work. And so if a function has, or sorry, if a class has any kind of abstract function, you don't really want it to be able to be instantiated, because then somebody might have access to the function or the, I guess we can't really have abstract fields, but the abstract functions, and we don't want them to be able to use it because it's not implemented. It's not actually written. It's just, we've given it a name, but we said, oh, we're going to write it later. Right, so it's not going to let me make an enemy anymore. So let's be a little bit more specific here, and let's make this enemy a walking enemy, which is the new class that we've created. And we're going to need a write-of constructor for that. I guess it's not looking at this one. Okay, so let's implement that really quick. So let's write public here, and then we will write really quick this constructor. So we'll say walking enemy, and that will take a position, and then we basically just wanted to do the same thing as the game object class. Why is this? No default constructor exists for game enemy. Oh, you know what? It would be easier. Oh, maybe I don't want that to be an E. Yeah, let's have this call this version, and let's have this one call the game object version. Actually, maybe that's not a good idea. Just have that call the enemy one, and then that will set things as it normally does, and then we'll set the character equal to W now. So that'll override it. So I guess even in an abstract class, I suppose you can implement methods and then, or functions, and then have them overridden. So here I'm just going to call the enemy version of the constructor, and then I will change the character, I guess, from an E to a W. It should let me do that. And then the other thing we wanted to do is we wanted to actually implement update, right? So if I compile it now, it should hopefully give me an error saying update. Walking enemy cannot. Oh, I suppose it automatically copies it over. That's interesting. It's a different error message than I expected. So rather than say you haven't implemented this yet, which is really the error why it's not compiling, we haven't written update down here. It, I guess, just assumes this is an abstract class because it will copy the abstract method. So it'll just, since it's inheriting from it, copy this down to this one here. I suppose that's okay. It's just maybe not the most helpful error message. So really quick, let's write void update. And then we will want the enemy to walk back and forth. So perhaps a good idea here is let's just move into direction. So let's give them a direction to walk. And the way I normally do that in games is I just set equal to 1 or -1. So let's just have it walk right, which is +1 by default, and then it will turn around and walk -1, I guess, when it hits a wall or something. So we'll say something like if direction is positive, it's greater than 0, and Oh yeah, we had res y, that was like the thing. Direction is greater than 0 and position dot y equals res y. So if it's about to run into a wall, so if it's moving right and its position is the far right, then we want to turn it around. So direction equals -1, and then we'll say else if the direction is negative and the position is the far left, then we'll say that we want it to go right. So this is just code to turn the enemy around. And then I'm just going to update its position. So position dot x plus equals direction. So this will just move it right or left, whichever direction it is facing. And then the last thing we want to do is we want to add it to the screen, which again we can say is in the game object update function. Oh, and that requires the screen, huh? So I need... I suppose I need this still. So this was just the argument to our call normally. Identifier screen is undefined. Oh, am I making a mistake here? Ah, whoops, I forgot to put that in the enemy class. So really quick, let's go down here, make sure that's there. Oh, right, sorry. I'm thinking of C#. The indexers go after the variable name in C++. Okay, so now hopefully it should say this isn't abstract because I've actually written this body here. And it should run. Okay, awesome. So we've taken that update that we had here, which was marked as abstract, not implemented, and we implemented it, so now the compiler is fine because it can find something to call. Alright. And so we should see that, yeah, the enemy is going to walk to the right and then completely disappear. Very cool. And I'm going out of bounds because I'm doing that apparently. So something's off with my logic, I guess, but definitely not with our code as far as compiling, so that's good enough, I suppose. We don't need a functioning game, we just need a game that runs. That's how we make money. I joke. So I'll fix that maybe later before I upload it to Canvas. But does everybody get the idea with what we were doing there? That we can take these specific objects and make them do new specific things, and then kind of have like a baseline thing for them to work with. So in this case, an enemy that that just describes what they should actually do, but doesn't actually give a definition on how to do it. So here this really just says that enemies are going to have the ability to update, but it doesn't actually tell them how to update. It forces them to specify that themselves. Any questions on abstract or virtual functions in classes? I guess if anybody has any questions, just stop me. I think we'll spend the last 20 minutes or so talking about assignment 4. Assignment 4, and I'll fix this and upload it to Canvas later, so that's actually functioning like a real game. If direction is greater than, I just don't know why that wouldn't work. Oh well, not a big deal. Oh. Actually, I think I just fixed it. Let's check it really quick. Let me try moving left here so that we can get a better look at the enemy. So you can see the enemy moves right and then still clips through the wall. Man, I'm a bad game developer. Oh yeah, I'll have to take a look at that. Oh well. Okay, yeah, let's talk about assignment 5. Let's not spend too long making the game actually good. So we got a mess of JPEGs here. So for this assignment, we're going to be working with abstract and virtual classes, which is why I talked a little bit about it before talking about the assignment. But you're going to have two programs actually this time. So we're going to have a program that's full of abstract and virtual functions. And then we're going to have another class which does code generation. We'll explain that when we come to it. So hopefully, if you're not familiar with Inspector Gadget, it's a cartoon. It has a live action movie. I remember watching it as a kid, but he's like a detective, and I guess he uses specific things. So like he has a copter. There was like some list that he had for all the gadgets. So he has like binoculars. So he's like all these gadgets that he can use, right? So what we want to do is we want to create an abstract class of gadget. So just a generic gadget thing that describes what a gadget is. And then we're going to have inherited versions of that, which implement the abstract class. So for instance, the helicopter, that would be an example of a gadget. So it's going to inherit from the gadget class, and it's going to be its own specific instance. But we can't make just a gadget because, again, that's not specific enough. We don't want that to be instantiated. And then, like, same thing with binoculars. We'll make an inherited version of that. So essentially, you're going to need to write all of these gadgets, and we're going to get to how you actually are going to do that, and then store them. So we'll have an object that represents Inspector Gadget himself, and then we will have a way to call all of his functions. So let's take a look at the code really quick, because I think, excuse me, I think that will explain it a little bit better than I can do by just looking at this PDF. Oh, other thing, I updated the code for assignment 5 last night. So if you downloaded it earlier, if you really wanted to get started on it early, please make sure to re-download it. I just added some comments to help explain some things. So let's take a look at this one first. So this is main. I recommend implementing this program second, but I think it's important to understand this one before we move on. So we have two types of inheritance here. We have an entity type, which is just kind of like almost like the game object I had. It's just kind of a generic type that that has some descriptions, but isn't really anything in particular. So this is an abstract type. You'll see it has an abstract destructor here. So virtual destructor, but it's also abstract because it's marked as 0. And so we can't actually instantiate this here. Right, so this says here, this makes it so you cannot actually instantiate it, but you can make derived classes. So you don't actually need this line particularly, as we just saw with my code, but that's not bad to have. So we won't be able to instantiate this because it has an abstract method, which is fine because we don't really want a specific entity. Now we have two things that inherit from entities. So we have the gadgets, which are going to be the things that you actually use. So you're going to need to write in some way all the gadgets that inherit from this. So like the binoculars, the copter, maybe like a hand. There's a list of it in the actual file. And then we have the Inspector Gadget type. So this is like Inspector Gadget himself. So this is like a person. And so this one also inherits from entity. It has a name and all that. So we have the constructor here. And so what this will do is it's going to, like my comment has here, it's going to read in from this file, which I'll pull open in a moment, and it's going to create all the gadgets listed there. So it's basically going to, let me find it really quick. It's basically going to read in a string and then figure out which function it needs to implement or instantiate based off of the string. So, programming assignment 5, shared, input. Right, so there are two files, or I guess there's a couple files. There's two files I'm going to talk about. So this is the one that we're reading in here, gadgets.list. So it has the names of all the gadgets. So if you read binoculars, you're going to want to instantiate a binoculars gadget. If you see coat, you'll want to instantiate a coat. If you see umbrella, you'll want to instantiate umbrella gadget. So you basically read in all of those strings from this file that's given by this file name, and then instantiate based off of that. And you'll create a function that instantiates based off of the string, and then you'll need to store them in this gadgets array. I'll come back and talk about this in a little bit because it's implemented in kind of a strange way. I guess it's just there for the sake of practice. You'll notice it has 3 pointers, which is kind of nutty. The first pointer is a pointer to an array, and the other 2 pointers are for the sake of the array. So this is going to point to a 2-dimensional array. So you'll need to allocate it like a 2-dimensional array as well. So that would be something like gadgets equals new gadget t, and then we just put the 2 numbers, right? And the way we're going to do that is based off of this length and the width. So the length is going to be the second dimension, it should be, of this array, and the w is going to be the first, I believe. He has that written in the rubric, but I think that makes sense. At least it makes sense to me to do it that way. Right, so the way you instantiate an array, just to remember, is we use the new keyword and then we kind of write it like we would a normal array. So in this case it's 2-dimensional, so we'll have that. So it's going to read in all of those, put those into the array, and I'll go over how we're actually going to do that because it is 2-dimensional, I guess, just again for the sake of practicing some computer science concepts. And then we're going to do this build of a file. And he has a description of that one in there. And then we have deconstructor. That's just going to deallocate the gadgets array, so you'll need to use the delete keyword and then just delete it. That's all you should really have to do there. And then there's 2 other real functions here. There's those print gadgets. This one should go through the gadgets array and just print all the stuff. So you can do this with 2 for loops, just iterate from 0 to L and then 0 to W, and then print all of those. Oh yeah, make sure you set L and W as well. So you have this L and W, and then the actual one that belongs to there. So doesn't the variable in the array have to be a const? Good point. So it doesn't actually have to be. Some compilers will give you an error if you don't. This one should allow. I'm assuming he tested it beforehand, but yeah, that's a fair concern. In general, you should use a constant. If you use the standard C++11 compiler, it should allow you to do it, but it won't be a normal type of array. It'll be like a special type of array. It just won't tell you. So yeah, fair concern. I think with the way he's written it, it should still work though. At least I hope so. Otherwise we're going to have an issue. If that's the case, then it's okay, I guess, to move these to be a constant. Right, so yeah, go through the array, print all of those, and then this one is basically just the same thing. Go through all the array and then call GoGoGadget on all of them, which is basically just the use function. It's kind of like the update that I wrote. So, oh yeah, I guess we go back up to that gadget class that inherited. They're all going to have a pure virtual function called GoGoGadget, so it's going to look a lot like this. So you're going to want to write it so that it's so there's a function called GoGoGadget, and that just uses the gadget itself. Right. So this one I still need to take a closer look at. I believe it builds some sort of file described by this file name, which I think is the gadgets.list2 in the actual input that I gave. And then here we have the GoGoGadget, which is just going to take this string. It's going to look through the array. So it's going to go through, again, like for int I equals 0 until L, j equals 0 to W. And then if it finds the oops, if it finds a gadget with that given name, then it will call the go gadget for it. And then he's written a main for you that does that. So it will call this, which should read in the file and make all of the go gadgets, or the gadgets, and then this will make the binoculars work. And this one will print all of it. This one will build a new list, and then these ones will call the plane gadget, the parachute gadget, etc. So that's just an overview of this one. I think this is the harder part of the assignment. I'm still not entirely sure what this function does. I was trying to figure it out. And then there's also the fact that this is a 2D array, which we'll talk about in a moment. So then we have another function, or sorry, another program. So that's the second program I would say that you should work on. So that's the actual like main meat of the program is there. And then we have a second program that you're going to need to write that does code generation. So what this function does, or not, sorry, this code does. So we have this skeleton skynet.cpp source file. It's going to make a program that generates the header file for this one here. So you'll see here it has include gadgets.h, but it's giving me an error because it's not actually written yet, hopefully. Please update your include path, yeah. So there's no gadgets.h written for you that contains like the binoculars and the umbrella and the helicopter, that kind of stuff. Not written for you. You're going to have to write it yourself, but with the way we want to do this, we're not going to write it ourselves, and maybe we want it to be a little bit dynamic and actually generate it based off of a new list. It will generate the code for us rather than us having to write it every time. So this program is going to generate all of those classes from a file so that it will actually generate the header file. So I will pull this open here. I notice this is formatted a little bit strangely, and I might just update it. I'm not really sure why there's slashes here. But he gave a list of all of the gadgets that you'll be able to use in your program. So we'll have binoculars, umbrella, coat, copter, cuffs, hands, arms, etc. But now these are separated with a slash, so I might end up removing that because I don't really think that's easy to read. So you'll notice here, kind of like the first assignment, the reading is going to be a little bit different. So the first word is always gadget, which we don't really need. And then we have the name of the actual gadget. So you'll want to basically read the first thing, throw it out. Read the second thing, that's the name it actually belongs to. Read until a colon, and then the rest of it, that's the description of the object. So you'll need to read the name before the colon and the description after the colon, and store them both as strings for each object. So that's what read file will do. It will read all of those. And then it will store it into a vector here. And that's what we'll return. So it'll create a vector of these gadgets, which is just the name of the object, which is the thing after gadget, and then the description of the object, which is that whole string. So you'll need to read those in. That one should be pretty straightforward, I hope. The build classes. So this one is going to actually generate the .h, the gadgets.h file, and this one will actually help a little bit too. So this is going to create all of the classes that are going to inherit from gadget t that we just saw in the other file. So you'll see here that I've taken an example from the PDF that he gave just for the sake of it. So for instance, if I encounter the first one, which was binoculars, I'll want to have a class declaration that looks like this and make the name from the file. So in that case, like the first one was binoculars, right? So you'll basically need to almost hard code this text here and then have it generate the word binoculars and have it inherit from gadget t. So really this one, you can kind of just copy and paste the stuff I gave and then replace each of these in your print statement with the string name that you have. So these are all just the name of the thing. And then what the class will have is it will have a constructor that just sets the name of the object to be the name as a string that we already read in, and then it will have a function called get go Gadget, which will just print out the description. So you'll need to write, something that generates the standard C out. So really, you'll just need to copy and paste that and kind of fill it in, and then I've given a detailed explanation up there. And then the other thing you're going to need to write is a function that's not in any specific class, that's just kind of there, that he called a magic function. And what that will do is we'll use it here in this one at bare minimum. I guess we'll also use it in the build file, or this one, I guess. Is it will go through, actually sorry, no, just this one. It will go through, and based off of the string that it read in, it will instantiate the proper thing. So for instance, if I read in a file that said binoculars, I would want to instantiate a binoculars object like this. So you're basically going to need to write a function called magic function that has a bunch of if statements that say if gadget name equals the current name, instantiate a new thing of that. So we'll set this pointer g equal to that. So again, you'll kind of be able to get away with just copying and pasting this over and over again. Copy and pasting it in the context of like a for loop, right? Because we're going to have a vector to read through. And then filling in the name that seems to be there. And if you want to use a switch statement instead of the if that he gives, that's okay too. So this program, just to summarize, is going to generate the header file that the other program uses from a file. So it's doing a little bit of code generation, I guess, just as a bit of a practice on that concept, since that is really what a compiler does, is it takes in text like this, right, and then it turns it into actual usable code, in that case machine code for the sake of the computer. So a compiler really is just a program, right? It's just a program that takes text and turns it into code, like real code. So every CPP file you've written is just, a text file. Okay, so I think that about covers assignment 5. Does anybody have any questions on any of that? It is a lot to take in. When you build a file, I'm guessing you would use ofstream to write into the header. Yeah. Yeah, so in the constructor there should be one. Where is it? You're right, there should be one somewhere. Vector Gadget. Does he have a... Ah, yes. You pass it here. Yeah, there it is. You'll pass the file out here, and it's written in main. So, here it is. So he opens it here using the command line argument, and then passes that open file to write to for your two functions. So that'll be that one and that one. Any other questions on any of that? Or on anything in general, I guess? Okay. Well, I don't think there's anything I can really talk about for like 2 or 3 minutes. So I'll stick around for another 3-4 minutes, just until the time ends. And I guess you're free to go, but if you have questions, feel free to ask. You know what? While we're here, I'm just gonna try to fix that game object. That would be why. Still nothing. Well, I tried. Okay, that works now. Well, at least I managed to get it done before the end of class, I guess, even if nobody's here. Okay, I guess I will see you guys on Wednesday then.